Today we are going to learn about triangle similarity and the trigonometric functions sine, cosine, and tangent. But firstly, let's take a look at similarity. When are two triangles similar? Two triangles are similar if one could be mapped into the other using a set of rigid transformations, meaning reflections, rotations, and translations, and scaling. So let's take a look at the four cases of triangle similarity. These work vice versa. So if two triangles are similar, they share these traits, and if they share these traits, they are similar. So it works one way or another. Firstly, we are going to take a look at these ones. The first is angle or angle, meaning if alpha is equal to alpha, beta is equal to beta, so they are basically sharing at least two angles, because if they are sharing two angles, if you think about it, that means that they are also sharing the third angle. And then these triangles ABC and triangle DHF are similar. We usually have this sort of way to mark it with this little line here. So this would state that these triangles are similar. So where's this angle? Next is side, meaning if the ratio of their appropriate sides are the same, then they are similar. Right here we have A divided by F, or sorry, not F, but D. So if A divided by D, because those two sides are appropriate, this could be told by looking at the two triangles, but we should always sort of be conscious, because just because two triangles are looking the same, it doesn't mean that they are the same. And that doesn't mean that the side A is going to be appropriate to side D. So if we would have angles, that would really help us. So if we would draw the angles, but we aren't looking at the angles right now, these are just here to help us. So if we have these ones, we would say that the side, let's say D, is appropriate to side A because they are both between angles gamma and beta. So that is sort of a benchmark for it and the way of looking at it. So it B divided by A, and then we have C divided by F. If we would do any of these, we would get the number 2. So it means that they are equal. So this is the third one is if we have A, so this is side A divided by side D is equal to side B divided by side F, and gamma is equal to gamma. So if two of their sides and the angle, so if the ratio of two of their appropriate sides and the A is the same, and the angle in between those sides is the same. And the last one is just a sort of like last one, which you probably aren't going to use anyways, which is the one where the ratio of two of their sides are the same, and the angle opposite of the side which isn't the smaller, so meaning the side which is larger, or it could be as long as the other one, is the same. But that is just some sort of an addition. You don't really need to know that, because they usually aren't asking it. So from this similarity, we could firstly we could say that if we have a triangle right here, which is sort of a half of a regular triangle, so half of an equilateral triangle with angles 30, 60, and 90, we could very much say that this is 90 degrees, and we are going to construct right here once again a same triangle with the same angles, knowing that this right here means that a similar triangle with sides. So this was just scaled by the scale factor of 2, so each side was multiplied by 2. And this right here is basically meaning that if we would take a look at the ratio of the sides, once again we could see that 2 times the square root of 3 divided by 2 is going to be equal to the square root of 3 divided by 1. So if we have a triangle and we know the angles of the triangle, we could definitely state that the ratio of the appropriate sides will always be the same regardless of the scale factor and regardless how big or small that triangle is. If the angles are the same, the ratio of the sides is the same. And we sort of, and I mean not we, but a lot of smart mathematicians back in the day figured out that we could use certain functions to represent the certain angles. But first, let's talk about what the opposite, adjacent, and hypotenuse means. Friendly reminder: these only work for right-angled triangles. So I mean, so there are applications of sine, cosine, and tangent outside of right-angled triangles, but you are mostly going to learn about applications inside right-angled triangles. And we are always talking about the acute angles of a right-angled triangle. So if we take a look at it, it's always going to be the angle which isn't 80 degrees, so the one of the other two angles. If we are taking, we are right here in the top right corner. If we are taking a look at the sides in from the perspective of angle alpha, this one right here, we could see that there is an opposite side to it. There is the hypotenuse and there is the adjacent. Opposite meaning it is sort of in front of it. Adjacent meaning it's next to the hypotenuse. We already know that that's like the longest side of a right-angled triangle. And we figured out some trigonometric functions for it, meaning that the sine of an angle is equal to the opposite side of that angle divided by the hypotenuse. What do we mean by here? Let's say if we would like to know the sine of 60 degrees, so right here, the sine of 60 degrees is equal to the square root of 3 divided by 2. And why is that? Because some mathematicians told us that if we would say that the sine of 60 degrees is something, then that would mean that the side opposite to it divided by the side uh, divided by the hypotenuse. And if we would just grab a calculator and we would type in the sine of 60 and press the thing equal, it will either give you the square root of 3 divided by 2 or something like 0.866, which if we would type in the square root of 3 divided by 2, it will give us the same thing. So this is kind of a cheat code for solving problems with triangles. So the sine of a triangle is equal to the opposite over the hypotenuse. I got this so katoa. This is like a popular expression helping to memorize and understand the sides. We also have cosine. So let's say the cosine of 60 degrees right here. We should look for the side adjacent to the 60 degrees. So that is the side with 1, with this, with the length of 1, and that is divided by the hypotenuse, as you could see here. So that is going to be 1 over 2 or 1/2, and the tangent of 60 degrees is going to be equal to the opposite over the adjacent side, meaning if we have 60 degrees right here, we have an opposite over that which is the square root of 3, and then that is divided by 1, because to this 60 degrees the square root of 3 is opposite, that comes in the numerator, and 1 is adjacent, and that comes to the denominator. And if we would take a look at it, and like these things, we could always see that these are true. So if we would type the square root of the sine of 60 to the calculator, we would get the square root of 3 divided by 2. So that value, and we have this for every triangle. We have this is a isosceles triangle, which is right angled. This is like the other popular triangle that we are usually dealing with. And we have a lot of other stuff, but this is the main thing that you understand this. And this is like a popular term, which is SOHCAHTOA. And if so, it's 9 letters, and it is divided into three times 3 letters. The first letter is always the name of the function. The second one is the thing that comes in the numerator, so the thing you divide. And the last one is always the thing that comes in the denominator, so the thing that you divide with. So these are because sine is equal to opposite over hypotenuse, kach, because cosine is equal to adjacent over hypotenuse, and toa, which means that the tangent is equal to opposite over adjacent. So we have these values right here, and if we would write the same things up for for 30 degrees, so the other acute angle of a triangle, let's say the sine of 30 would be equal to, so now be cautious because sine is opposite over hypotenuse. If we have this 30 degrees, the side opposite to this 30 degrees is this number 1, the side with length 1, and the hypotenuse is always the hypotenuse, so this is going to be a half. The cosine of 30 degrees is going to be equal to, so yeah, we have this 30 degrees, and the side adjacent to the 30 degrees is the square root of 3, and the hypotenuse is just 2. And the tangent of 30 degrees would be so opposite over adjacent, so opposite is 1 and the adjacent is square root of 3, so this is just 1 divided by the square root of 3. And yeah, these are ones, and if we would like write up everything, by the way, you should, as practice, you should try this one. This is a pretty easy one because the opposite and the adjacent sides are the same, by the way. But if we would just take a look at these are some common values. I will take a look at this one as well, but we are working with this one for now. If we would take a look, the cosine of one acute angle is equal to the sine of the other acute angle. So these work like this and this. So this one, sine of 60 is equal to cosine of 30, and cosine of 60 is equal to the sine of 30. So the sine of one angle is equal to cosine of one angle. This is something that we could take away and something that always works in trigonometry. And then the tangent of one angle is equal to the reciprocal of the tangent of the other angle. So you see the numerator and the denominator were switched. And if you would take a look at these ones, we should kind of see that this is that we should sort of notice or see why this works this way. So these are some important takeaways. Now we could try the one with the 45. These are the two values. These are like some values that you should know. Now I'm going to delete the board right here, and we did this and this. Now we are going to leave this one. Let's try to write up the values for the angles of this thing. And we are in a pretty good position because the two angles are the same because it's an isosceles triangle. So we only have to write up everything for 45. And yeah, we have the tangent of 45. And sine of 45, we could take a look at either angle because they are the same. Is 1 over the square is 1. So this is the opposite over the square root of 2. Or we usually just rationalize the denominator and multiply the numerator and the denominator by the square root of 2. This is just the square root of 2 over 2, because we usually, in the numerator, square root of 2 times the square root of 2 is just 2, and 1 times the square root of 2 is 2. Cosine of 45 is going to be the same once again, because this is adjacent over that, and tangent to 45 is going to be 1, because that's 1 over 1, which is 1. So yeah, we should memorize SOHCAHTOA, but otherwise this is the everything that we need to know. Now let's take a look at some problems related to these triangles. Now right here we are given a x is the thing that we are trying to figure out. Now we are looking for the function with the opposite side and the hypotenuse, which is going to be sine of 40 is, you can just type sine of 40 is equal to, and you will get a value right away, but as you wish, is equal to x, because that is the opposite side of this 40 degrees. It's here right in the top right corner. Remember SOHCAHTOA, and divided by 30. So we should multiply each side by 30 by the using the rules of algebra, and this is going to be the sine of 40 times 30 is equal to x. And if we would type in the calculator, obviously we are going to need a calculator for most of these problems, and this is going to be equal to something like 19 point let's round it up to 2 decimal places, 19.28. Next one, we have a 35-degree angle here, and we have this one and this one. Which side to the 35-degree? So not 35. Sorry, I'm talking. It's not 35. It's 33. So this is a 33-degree angle, and we have 7 as a side and x. So which trigonometric function works with the side which is adjacent? The hypotenuse is the function cosine. So the cosine of 33, we will get a value for that in a minute, is going to be equal to 7 divided by x, and then x is going to be equal to, we can multiply each side by x and then divide by the cosine of 33. So these two could be switched, and that is going to be equal to 7 divided by the cosine of 33, which is, if we take a look at it, is just, let's type it in the calculator, everyone, 7 divided by the cosine of 33 is 8.35. Let's run it to 2 decimal places once again. And we have this one. So right now to this 27-degree angle, we have the opposite, and we have the adjacent, which trigonometric function deals with opposite and adjacent. Yeah, it's tangent. So the tangent of 11 divided by x, because opposite over adjacent. Sorry, tangent of 27, shouldn't leave that out here. This, and then we could say that 11 divided by the tangent of 27 is going to be equal to x, because once again we did the same thing as here. We switch these two by multiplying by x and dividing by the tangent of 27. And if you type this into the calculator, 11 divided by the tangent of 27 is equal to, round up to 2 decimal places, 21.59, let's say. So yeah, this is how you solve it. This is going to be our next problem, but if we don't round the angle. But for today, I think this is enough. Have a nice day, everyone.